In this video, we are going to learn Sidecar pattern and how does the Sidecar pattern works for microservices deployments. The Sidecar pattern is a design pattern in which a helper container is run alongside the main container in a pod. The Sidecar container performs cross-cutting tasks that are related to main container. One common use case for the Sidecar pattern is to add logging and monitoring functionality to a container. For example, you might have a main container that runs your application and a Sidecar container that runs a logging agent that sends the application logs to a central logging server and also provide the monitoring the health of the main container. Applications and services often require related functionality. For example, monitoring, logging, configuration, and networking services. These cross-cutting tasks can be implemented as a separate service with a Sidecar pattern. You can see the image on the slide. Here is the host application and there is a primary container which is the core functionality and deployed as a container for our application. And alongside there is a Sidecar container which is perform peripheral task, which is the cross-cutting task related to logging, configuration, monitoring, healthcare, and so on. So this is an example use case of Sidecar pattern. So the Sidecar container and the main container share the same network namespaces, which means they can communicate with each other using the localhost. This allows the Sidecar container to access and manipulate the data produced by the main container as needed. So now let's check the benefits of the Sidecar pattern. The Sidecar pattern has a number of benefits. It allows you to add functionality to a container without modifying the container itself. And this can be useful if you want to add logging or monitoring functionality to an existing container image that you don't control. Also, it allows you to decouple the main container from the Sidecar functionality, making it easier to update or replace the Sidecar without affecting the main container. It allows you to run multiple containers in a pod that share the same network namespace, making it easier to communicate between them. It allows you to add common functionality to multiple microservices without having to modify the microservices themselves. This can make it easier to manage and maintain your microservice deployments over time. And also, there are a few potential drawbacks to using Sidecar pattern for microservices, which is increased complexity. By adding a Sidecar container to your microservices, you are adding an additional layer to complexity to your deployment. This can make it more difficult to understand and troubleshoot issues that arise. Another drawback is increased resource usage. Running an additional container in a pod will increase the resource usage of the pod. This can be especially problematic if you are running many pods with Sidecar containers, as the resource usage can add up quickly. Another drawback is decreased performance. Adding an additional container to a pod can potentially decrease the performance of the pod, as the Sidecar container will be competing for resources with the main container. This can be especially problematic if the Sidecar container is performing resource incentive tasks. Another drawback is limited flexibility. The Sidecar pattern can be inflexible in some cases, as it requires that the main container and the Sidecar container run in the same pod. This can make it difficult to add functionality that requires a different container runtime or resource constraint than the main container. So these are the drawbacks, and now let's check when to use Sidecar pattern into microservices deployments. There are several situations in which the Sidecar pattern might be a good choice for adding functionality to microservice deployments. So the first reason could be when you want to add functionality to an existing container image. That means if you are using a pre-built container image that you don't control and you might not able to modify the image to add additional functionality. In this case, you can use a Sidecar container to add the functionality without modifying the main container. And the second reason could be when you want to decouple the main container from the additional functionality. By using a Sidecar container, you can decouple the main container from the additional functionality, making it easier to update or replace the sidecar container without affecting the main container. Another reason is when you want to run multiple containers in a pod that need to communicate with each other. The sidecar pattern allows you to run multiple containers in a pod that share the same network namespaces, making it easier for the containers to communicate with each other. And another reason could be when you want to add common functionality to multiple microservices. This is very common reason to use sidecar pattern in the real world microservice applications, because the sidecar pattern can be useful way to adding common functionality into multiple microservices without having to modify the microservices itself. This can make it easy to manage and maintain microservice deployments over time, because we can add common functionality without affecting the actual application microservices, and we can manage them in the sidecar patterns. So the sidecar pattern is useful tool for adding functionality to a container without modifying the container itself.